We are live.
I think that's it. If anybody's here, if you can you guys hear us okay? No, there's no way to know.
Yeah, I guess I should look at the camera. Just looking for confirmation that people are actually seeing us.
Go check in there.
I guess that's true.
It's good. It's a good point.
Here, how about I go?
All right. Monkey with the wrench.
Okay, so we are on.
I take it you can hear us?
Just say yes. Can indeed see, yes, and hear.
Hey,
Hearing is the good part.
the Savant. How's it going, Jonathan? Awesome. All right. Well, you get started. I'll let you take off.
I figure since we're probably gonna wait, to get into questions till like a lot of people get on the screen. So the monitor's here. That's why I keep looking over there. Camera's here. While we wait for people to get on to maybe get to some questions, I figured it'd be maybe a good idea to just tell like the story of this project over the last 4.5 years. So, well, actually more. It's been public for 4.5 years. Kind of goes back a little bit farther than that. And, obviously I'm at the heart of everything. Lauren was here in the early days, and then as she's kind of faded out of primary relevance in the project, Michael has joined us. So to start, in 2017, right before I started working for Bigelow Aerospace. I got this concept. I was kind of working on a hobby build, and I thought, wouldn't it be cool to make like a potato gun, but to use like oxyacetylene for the fuel. And that got me started on this long kind of chain. And to the point I came to a fluid propellant project. That wouldn't just be a hobby build, but would be a serious firearm that was powered by a fluid propellant mixture, quite unregulatable in my estimation, but very different from the technology that exists now. And I started working on it, and I realized, man, this is like, there's a lot of problems here, but it's very difficult.
Dangerous.
Yes,
To test.
dangerous to do without a lot of very expensive equipment. So I started looking for friends to help me, and I found a guy named Mike Crumling, a gunsmith, who made some, what would you call it, like integral barrel cases for 3D printed firearms. I reached out to him, and I became great friends with him. He's a very good friend of mine to this day. And I reached out to Defense Distributed. Didn't really hear a lot, but let's see. After I left Bigelow, after Bigelow was over, I moved out to Tennessee. Yeah, Tennessee, to be with her. This is my wife, Lauren.
Hello.
And I didn't have a job in Tennessee. It's hard to find one. You think, maybe it'd be easy to get employment for somebody who was the engineer and a founder of a successful hardware startup, but apparently that's not true, at least not in East Tennessee. So I was unemployed for a while, and I worked with Mike on a lot of concepts that Atlas Arms had because we kind of figured out, well, we need to start on
something a little more easily achievable.
Yeah, right, exactly. To get the funding, the reputation to start building for the fluid propellant. That's still one of our highest goals here at Atlas Arms, but we need to start with smaller stuff. So a lot of this is, some of this is talked about in the manual, and I hope that this live stream will get into some of the contents of the manual. Though we're a little bit limited on some of it by governmental regulations, but yeah, some of this is in there. But started and then kind of came to this realization that this concept for an AP armor penetrating bullet that is federally legal or kind of bypasses the federal legislation would be a good place to start. And so that's what led us to this project first. So then I found gainful employment. I was I was almost abusively underpaid, but it was enough. It was enough to get the project off the ground. I had seen in the news something about gun dynamics. I knew this, even the Dagger project would be pretty expensive to develop, very serious and expensive. So I figured, instead of just asking people to give me, some unknown guy on the internet, a bunch of money, I decided that I needed to develop a corporate face. We would need to have a nice crowdfunding video and a third party to take the funds for us. So we can't use Kickstarter, we can't use Indiegogo because firearms related, which is kind of a running theme about how difficult. In fact, actually, we had a hard time finding somebody to do the crowdfunding video because of the controversial and the firearms nature of the project.
It's been a repeated issue for us in the last several years.
So so we went with Gun Dynamics hosting the crowdfunding campaign for us, and
which was developed specifically to be a competitor for, well, maybe not, I guess not a competitor, but was specifically designed as a crowdfunding platform for firearms related technologies, given that Indiegogo, Kickstarter, etc. wouldn't take those.
Right. So let's see. We incorporated the company. We got 501c3 status, which I was ecstatic about. I was kind of concerned that they wouldn't give it to us for obvious reasons, but they did. Let's see. Remember, at the time, we'd go over to these rooms, these study rooms at the University of Tennessee, where Lauren was a grad student, Lauren helped me build the website and get everything ready, script the crowdfunding video. I mean, just all of the beginning stuff. And we launched on, I think it was January the 18th of 2019. Was that it?
Yes, I believe so.
So that was the beginning. People started to give us money very quickly, which was great. But just the crowdfunding site had it. We didn't have it, but we figured, well, since people are giving us money, we should start on this. So we got a ransom risk. You can look that up if you don't know what it is, and had a local machine shop make us some cores and jackets of the initial design for very cheap. And it was so cheap because this is precision mill rights.
Well, I wouldn't say very cheap. It was just very cheap compared to the other options, which wanted to charge a minimum of $250 no matter what we did, because they didn't do small parts.
Which makes sense, you know. But
it was obviously prohibitively expensive to begin with.
But some of basically we got them. They were already cheap, and then we got them to give it to us half price because, and when we gave them a donation receipt, so they donated half of the work to do it. And then we paid for half, and that got our toes wet in Tennessee, and we were doing our work in a ransom rest because we didn't know what kind of pressures this was, were happening in the gun. We used a Canik TP9 SFX, if I remember correctly, for those initial tests, and we had a few that survived, and that was survived to the target rather than breaking up, and that was pretty cool. But we figured, well, we got to start doing pressure testing. We got to do this the right way. As it turns out, there's like 4 companies in the United States that make pressure testing equipment, or universal receivers, which you can see are set up behind. I think there's our universal receiver back there, set up on our test bench with the universal receiver, the chronograph, and the bullet trap there. But the problem was that those cost like $15,000 new, right? Well, we couldn't afford that, especially not with the, we didn't even have that much in crowdfunding, and the crowdfunding site hadn't given it to us yet. So
Alice Arms, yeah, which means that Alice Arms began on a grad student salary, really.
Yeah,
Got half of an engineer's salary because that's about how much you're making is half of an engineer, and then finally, yeah.
Right. So, but you know, we did a lot of due diligence and bought a universal. We were able to find some that had been refurbished, some old URs that had been refurbished. We bought it for I think $5,500. Yeah, that's. I mean, you're really lucky to find that deal. We lucked out on that. And then it was $1,500 for the pressure sensor, and $650 for the test barrel, and then we had to have the electronics to go with it. PCB, the company that makes the pressure testing equipment that Sammy's specification calls for, we went around and around with them. They wanted to sell us some stuff that was needlessly expensive, and we had to kind of talk them down. And finally, we got the pressure testing stuff right at the end there in Tennessee. But Lauren's, I think I was working for Global Marine in Tennessee for about a year and a half. And then we moved to Arizona, where Lauren's
my graduate advisor and his wife got jobs in Arizona. And so I had the choice to stick with them and move or get a new advisor. And neither of us were really that big fans of Eastern Tennessee. And I didn't want to get a new advisor midway through my dissertation. So we decided to up and move.
So to Northern Arizona, we went to Flagstaff, and that was great. That was actually a fantastic opportunity. But once we got there, we realized, it's like the shipping, to have these bullets made in Tennessee and shipped to Arizona is terribly expensive. We couldn't find anybody to do it anywhere near prices we can afford to make our prototypes. So we said, well, I guess we have to do it ourselves.
And on top of that, we were dealing with issues with the prototypes that we were getting, because even though the machine shop we had was doing a pretty decent job, the prototypes they were giving us were still not very in spec, because it turned out they were using a manual lathe or a CNC lathe, but not.
They had a single tool. It didn't have like a tool changer.
Yeah, so
but that's
the
what we
parts
could
were out
get
of
for
spec.
the money we were paying.
Right, sure,
So,
but that also factored into deciding to do it ourselves.
And you might say like it's this odd thing, and then it's like, well, what kind of lathe do we need to buy? So we're like, well, we could buy the Harbor Freight Special, right? Do we need to buy a mini lathe? It's like $600, $800. That could get us by. That's more in line with our budget, yeah. But they got like runouts of the best of them has got a run out of $1,500. And the question is, well, we're developing this new bullet. It's our job to say what the tolerances need to be. We don't know yet what the tolerances need to be.
So we had to make it as good as possible until we knew what would be okay.
So luckily, Take Tools is they make you could say really, really high level hobbyist lathes or the really low level professional lathes. They're in the Phoenix area. So we drove down and we picked one up, fully assembled from them. They're top of the line model. It's CNC. We've got a video of it on YouTube, but that set us back another several $1,000s, and still by this time we were still. It was hurting cats to get the crowdfunding site to give us any of the money that they were taking in for us. I think at this time we had raised like 10,000 or something like that. And I had to call them and leave messages and say, look, we need money. Like, we need the funding that we've raised.
I don't think by that point we'd gotten any.
Yeah. So finally I got through them like, oh, okay, well, we'll send you, 3,000 for now. Well, that gets you by. Like, okay, yeah, fine for now. And we were kind of tied too, because most of the campaigns that were on there, they were hardly making any money, but they were also charging. They're also charging what, like
royalty kind of fee,
right? Like a 20, 25 in some
that's
cases.
what it was. 10 to 20%.
But they were doing ours for free because nonprofit. That comes in handy, as it turns out.
Yeah. So we felt that it wasn't really in our best interest to be demanding, given that they were kind of doing us a favor. But at the same time,
And for the record, I think there's still money outstanding.
yes, they
They
still owe
They
us.
still owe us. It's taken
It's 1 to 4
years to get
3,000, I think.
the
they owe us.
entire, not even the entire balance of what was raised. So, to be fair, like, yeah, Atlas Arms Research raised a lot of capital, but it was
We still don't
working
have it all.
on it like pennies at a time because the Gun Dynamics guys wouldn't pay it out. And, like I said, I think we got a couple thousand earlier this year, and they're still out another 1,000 or something
I
more.
think it's 3,000.
3,000.
3. Yeah.
So
And then during
that's
this
been
time,
tough.
I'll say this: during the, and we get excuses from the guy Larry Lapata, and be like, "Well, my mom's got cancer. Well, my mom just died." And look,
I'm traveling, or I'm
we're
whatever.
like I gave this guy all the leash that he wanted, but then we come to find out, we found a record where he also recently sold a $3 million apartment in New York City. So he was, come to find out, he was probably using the crowdfunding that a lot of you guys donated that we didn't get until very late, for funding some speculative ventures in importing ammunition during COVID, when ammunition was hard to come by, and that failed, and so he couldn't repay us the money that he had promised because his gambling went bad, basically. So like for the first, basically for all of development, we were floating, on my silly low salary for an engineer, that is, we were floating all the costs of this project. And
That was just intense.
pretty
Once
tough.
we moved to Flagstaff for my benefit, you were then fully employed by Atlas Arms, which meant that we were then back on whatever you'd saved from that first job, and then back on your grad student salary.
Employed as in
So-
not. I was just working Atlas Arms full time. So, so we got the TAG lathe, and we could achieve tolerances plus or minus a 1/4,000, which is, what can you say? That's excellent. In fact, we had to run a space heater and a 3D printer and an air conditioner all at the same time, heating and cooling the room at the same time to achieve that precision. So
At the right time of day, so that the sun was either not coming through the window or was coming through the window
Right.
to keep the temperature the same.
but we didn't know. We didn't know what kind of tolerances it would take. So let's see. And then and as I talk about in the manual, technically, as far as this is going, we're trying to figure out what kind of adhesive we need to use. We're trying to figure out the tolerances we need. And man, just nothing's sticking. None of the adhesives were working. We were using Ultim plastic at the time. And man, just we're still getting called. 2 weeks ago, we got an email back from one of the adhesives companies we talked to way back then. We were talking to everybody, every adhesive company in the industry, looking for a solution to bond copper to Ultim. We did all the development with copper because it's similar to the MP35N super alloy that we use for the proper Dagny Dagger.
density.
Yeah, similar density, which is really helpful. But nothing was sticking. Out of desperation, we switched to polycarbonate and never looked back because it worked. It worked with Loctite 435, which is a rubber toughened cyanoacrylate. And we got the first reliable results. The first time that all the bullets of a batch actually stuck together, flew into the target, and made that perfect cookie cutter, wad cutter hole.
Prior to that, we would have some successes, but we would also have ones that exploded in the barrel, or we just have shrapnel flying everywhere. We lost a chronograph to shrapnel that killed it.
And that was our first indication, though, that
that
this
it
was going to
happening
be
early
really.
on, yeah. That it was going to be.
So
very
we'd
fast.
have, early on, we were getting, we get 2,200 feet per second with this bullet now. In the early days, we're getting 1,800 feet per second, and the jacket would shatter off of the core, either in the barrel or, shortly
Right.
after, at the muzzle or something. And we killed the chronograph because one of those shards of jacket broke off of it and just tore through the chronograph, despite a piece of well, no, we didn't have the polycarbonate.
No, we didn't have a shield yet, and then we got shields for it. So
And it tore in.
another one.
It was amazing the damage that this single fragment did. And we knew that, okay, this is going to carry, if a tiny little fragment of the very weightless jacket at very low energy can do that much damage, we know that this armor penetrating hollow point thing, it's real, and we can do a lot of damage to unarmored targets.
Got a relevant question.
Okay.
It's from JD Hill. Using your chamber pressure test rig, can you show the relationship, if any, between chamber pressure, velocity, and one bullet setback powder charge compression?
And one bullet?
I'm guessing you mean like how deeply you're seating the bullet in the case?
Yes.
How much you're compressing the load?
If that's what it means, then yes, we can. So we kept all throughout this process, from the precision millwrights samples to even now, we kept a monster master spreadsheet of everything, and that had,
every dimension we could think to measure that we could measure.
I mean, there was
And every
like
quantity.
9 different measurements for the jacket, 4 different measurements for the core, the eccentricity, the like the roundness of the core in the jacket, and all of that.
Links before and after seating the core in the jacket, right? Because
Yeah.
sometimes that changed oddly.
So, yeah, that's true. And so, yeah, we kept this master spreadsheet, and after every test, we would compare the results. And, if you're familiar with like statistical multivariable analysis, the idea is that, well, when you say, we want to say that if the test is to figure out, well, is our ogive shaped like this or ogive shaped like that, the more efficient option? Does that give us more or less energy per pressure? Then you also have to factor out all the other stuff that comes along with that, like the difference in mass and, like you're saying, the seating depth. So we know because we've had to kind of pull that variable out of it, that yes, seating depth does make a difference. It doesn't make the biggest difference, but you can see it. So I think in general, like, you wouldn't really see a clear trend unless you were off by, I don't know, 3 or 5 thousandths in seating depth, something like that.
So then he expands a bit, and basically, if you keep seating depth, powder charge, and those consistent, and then just use a heavier crimp, how does it change? And I don't think we've really varied the crimp in large part because you're not, the UR is actually calibrated to use NAS3 cases. And I guess for those that don't know, when you're pressure testing, you actually need to send rounds using the brass that you're going to use for your pressure testing into the company that what do they make, the sensor?
Mm-hmm.
Yeah.
And they will give you a calibration curve or correction to convert what that sensor reads to what the actual pressure is.
Yes. A voltage to PSI.
Yeah,
Not PSI.
something like that. Is it?
Yeah, they give you a calibration curve between
So-
the two.
You use that, but since we're using NAS3 cases, and you really don't want to crimp those too much. In fact, I think Phoenix was learning they were having some popped primers, and what the shell shock guys thought from that was that it was actually because they might have been crimping the case a little bit too much. So we haven't really played with that aspect of the load.
We use a light crimp because in AS3 or shell shock, people make it say they use a light crimp, so there was never really any reason to play with that. I'll say that the load is compressed, but that's not the big scary thing that I think kind of hand loading legend or myth has said that it is. When we talked to Ron Reiber, the head ballistician at Hodgdon Powders, I brought up that the powder load he suggested we use would be compressed with most bullets, and he said, don't worry about it. The pressure is the pressure. If you're measuring pressure, don't worry too much about it. And I think the reason why compressed loads are usually like this scary thing in hand loading, something to be avoided, is because if you're compressing it, then you could have an overcharge, and you wouldn't, like, normally you wouldn't, like, sometimes an overcharge because the volume is too high. And if you just compress it down, well, you might otherwise have caught an overcharge by the volume, and then you didn't because you just compressed it. I think I think that's the issue, really.
Yeah, given that we're measuring pressure.
What powder charge did we find worked best? Right now, it's Winchester Autocomp with 9.4, 9.3 grains of Winchester Autocomp. But one thing that'll be nice now that the manual's out, and obviously some people are working on the DIY, actually trying it out, see if they can do it. But when we have stuff out for everybody, and I know Gerardo, you keep asking it, although I don't see you on the donor list. But when we come out with this eventually, believe me, we want it out probably more than you guys. It'll be nice to see what other loads everybody else comes up with. And you want to know the reason we're trying not to give a straight up answer on when it's going to be out. It's because we've done that like 4 freaking times, and inevitably something comes up that like kicks us back and delays everything, and it throws wrenches in it.
Completely out of our hands.
The big thing, I'm just going to address this right now because I get everybody wants to know. That's the $1 million question. The big thing for us with this project, with the plan, was when we went. We've been making everything on a lathe, the cores and the jackets, and then we use the adhesive, and then we have our assembly machine. But through the DIY process, the way that works, it's all hand done on a lathe, and that's fine when you're making 1, 2, or 10 of these things. But what we found in this was that nobody wants to machine polycarbonate to tight tolerances in large volumes. And that meant that when we thought we would be able to release at the beginning of last year, that we weren't going to be able to do that. We had to find something else, or else the whole project was dead. So that other avenue ended up being injection molding. And we'd actually originally thought that injection molding was going to be bullshit, that there's no way we could injection mold jackets to the tolerances that we need. So, yeah. Anyways, that's what we've been working on for the last year and a half. This is a bag of prototype injection molded jackets. These are not good enough to use right now. We just finished, I guess, a month ago, our evaluation work on the prototype molds that the mold shop had built for us. And as a result of that, we weren't quite there, but we've learned what we needed to learn, and the molder has learned what they needed to learn to do this, and we're confident that we can actually mold these things. And as a result, we went ahead and put the order in. So about a month ago, we put the order in for our production molds. And I'm not one to normally say what our company expenses are, but that's almost $100,000. Right? All of the production, the manufacturing side of this is not coming from your donations, just in case anybody's wondering. We're not trying to make money.
I think the donors know
from the donors like that. The donors, will get rewards in terms of bullets and everything. And then we've released the manual and all the DIY stuff to the public. But yeah, this is entirely funded by us. And so we put that order in, and the lead time is at least 3 months. Probably 4. So you ask for a time. I can tell you it's not going to be in the next 2 months, but it'll probably be in the next 4 months. But I don't know, because inevitably things change, and we have to make tweaks or whatever.
So you guys ask us when we're going to have bullets. And then what we could do with that is ask our injection molder when we're going to have jackets. And then he'd turn around and ask the subcontractor that makes the valve gate when we're going to have a valve gate. And frankly, they don't care.
Yeah.
So, it's not that simple. Like, the economy is very complicated, especially with completely new technology for which there is no existing supply chain.
Yeah, nobody, and I'll say nobody. We're trying to hold tolerances to what, plus or minus on the bearing surface, what, a half a thou or something like that.
Half.
Plus or minus half a thousand, and nobody's doing that.
If you know anything about injection molding, the textbook tolerances for injection molding polycarbonate are plus or minus 2 thousandths, and we're trying to do 4 times better than that.
So like while this bag here, right? This isn't these jackets have some imperfections. I can probably find some in here to show you. But one thing that they are, even if their diameters or whatever are not quite what we need, they're not quite what we need, or they're not quite right. They are fantastically consistent, which you can see like a little bubble in that guy, right? We don't want that kind of thing. So this has been like the last year has been going through and optimizing the design of these molds with the mold shop to get this to be something that we can actually put in your guns. And the key on this is like, we don't want to put something out to you guys that is going to, not work. Right. And that's why it takes so long, is it needs to be perfect, because if it's not, then I don't know whose lives are being jeopardized because we gave you crummy ammo, and we're not interested in doing that. So another upside to the injection molding is the price per jacket is a fraction of what it would have been if we had even been able to machine it. So doing this, it's taken a lot longer, but we're going to be price competitive with all of the other premium defense ammo. Like, there won't be a reason to go buy Federal HST, because you can get better armor penetration and you can get better unarmored performance with this bullet. So,
and more consistency.
Yeah. So
That's the big thing.
That's for the like nutshell, like, why is it taking so long? When's it going to be out? That's kind of the big. Big part
I mean, you're jumping into the deep end. I was going to try to get there with the.
Yeah,
with the
sorry.
story. No, I mean, this may be long-winded. I just thought, I think a lot of people are like really, really in the dark about what has been involved in the development of the technology and trying to commercialize it. I think just like, I hope that telling you the story would help fill people in on kind of what it takes to do something like this.
So I know a lot of people think that this takes a long time, but or this project is taking a long time. But like we said in the beginning, the fact that it's a firearms project has added several complications, even to the fact of what bank are we going to use? Where are we going to put this money that we're getting from the crowdfunding or from wherever else? Because a lot of banks have in their terms of use that you can't use it for a firearms company. So then I read through numerous banks' legalese in terms of use to find banks that would be okay with our company.
Or even like hosting.
Hosting a website. Oh, how about GoDaddy, or I forget, all Blue Dog, whatever. There's all these different hosting sites. I had to read most of them. You can't have a firearms website. Or you could try, but they'd be within their rights to kick you off and not give you your money back.
Firearms are considered like a high-risk industry or whatever, which is fine if you have an existing business model. But when you have like a highly speculative business model, right, that's like, oh, we're just going to give our stuff away and tell people how to make it, then everyone's, well, gosh, I don't think I want a bank. I'm not going to give you a banking platform.
Well, and it's funny, and even kind of in line with that, Patrick asks about protecting IP. Well, like, our attitude towards IP is a little unconventional. We actually do have a patent on the Dagger, but the real goal with that was more to get the federal government to publish the dimensions and specs. Like, for someone who really wants to dig into the nitty gritty in a patent, you can take that patent and you can go DIY this. And that was our goal, because we didn't want to end up getting sued by Gerber Grual, for publishing, awesome shit.
Which, by the way, he's a terrible Sikh, because like
he should be armed all the time. What's
right?
going on,
like he's a Sikh, and like, if you didn't know, like, the Sikhs are a religion, and they're like religiously required to carry a dagger, a ceremonial dagger, on them at all times.
He should have our ammo.
As a symbol that they will use weapons to fight oppression. So like, why this guy hates guns is beyond me. But
right, yeah, and Patrick, I'm not trying to poke fun at you here. The secondary purpose here was actually to keep I think the attitude that we had taken was, if Federal or Olin or whatever, went to try and make this, our response would be, well, we have the IP, the patent, and if you want to make it, that's fine, but you have to release all your IP into the public domain or something like that. So that was kind of our plan a little bit, and it hasn't obviously come up. But and Jonathan, you're right. Like all of this, it's I've never heard it quite put like that. The solo pencil making problem with the addition of explosives. Yes, there is so much that goes into this. Nobody knows.
I always say, like, I think people are unaware. It's something like 2-3% of startup companies that are in like a startup incubator, for instance, actually end up a stable operational company. And then hardware is notoriously more difficult than software. When you're dealing with like real physical goods, then there's a lot more, with software, right? You got to have guys on a computer. You might need to pay for like hosting or servers, bandwidth, something like that. But we're moving like real capital around with the hardware company. So, hardware companies are even more difficult. And then, so it's kind of insane, it's like, what kind of person would go into a hardware startup in the first place, right? And then, well, we're going into we're a hardware startup inventing entirely new technology, which, by the way, I didn't know was possible when I started the project. To be honest, I hope that it was, but I didn't know for sure. So then you further complicate it. It's like, oh, okay, well, you're gonna take out an IP claim, right, on your idea, and then investors will buy into the company, and that'll get you off the ground. No, we don't believe in intellectual property, and we're not going to leverage it against people. So now we can't have any investment to develop it either. That's another level of insanity, raised. And then, and it's in firearms, which are kind of like a marginally legal industry. Financially speaking, in terms of investment and finances and banking and insurance, it's on the same level as like cannabis farming, right? Like that, and so then you go up another level of difficulty after that. And then on top of all of that, the purpose of the project was to fight the federal government, right? Like the world's most powerful organization. And you say, yeah, well, in an indirect and on a small piece of legislation, sure, but like Peter Thiel and Steve Jobs and whoever, like they write books on how to take your company from a concept to being in business, and still the vast majority of people fail at it. I was nuts. I was absolutely insane to take this approach. We've taken like every way we could possibly make this project harder and more ambitious and done it. And so yeah, like we're in totally uncharted waters while other people are trying to follow the coattails of Steve Jobs and Bill Gates or whatever. We're hacking our own path through the rainforest over here. So
we're in a garage, so it's legit startup. This is not a big money operation, but we're trying to use what we have as best we can. There were a couple other questions. Ladderman, are the penetrators still going to be manufactured on a lathe for production? And the answer is yes, but it's actually a screw machine. And then, in fact, for future runs, we're looking at a different kind, an schematic screw machine. But these are I guess, are we on a single spindle now or multi-spindle? I think they're using a single.
They're on a single spindle now.
So
They've just got a room full of them.
This is like CNC from way back when. They literally use ground wheels and cams. That's the program, and that's how they're turning these cores. And that was another challenge on the manufacturing side was trying to find a shop that could give us the volume making copper, because copper is sticky. Machine shops don't like copper.
It's a 20% machinability for all you guys that know what that means. It means that it's awful to machine.
Yeah, it gums up tools and it
And to be fair, like solid copper bullets that people use, they use what's called free machining copper, which is to say copper that has a bunch of additives and make it a lot easier to machine. And they
sulfur or something.
Yeah, I think it usually includes sulfur, maybe a bit of lead, and it makes it a lot easier to machine. That would be like what Lehigh and Barnes and those guys.
And
use.
Lehigh is making all of theirs on actual Swiss machines, which would be awesome. I'd love to do that.
But the reason we
Yes.
don't do that, the alloys that we use are stronger and harder, and it makes a better bullet. It makes it better penetrating. It makes it more reliable. It has more consistent performance in the terminal region, whether in just the depth of the penetration or in expansion and wounding. So there's a difference.
As far as what kind of machine it is, I have it in my email. I'll see if I can find it and tell you. I mean, a dream for us would be to have a bunch of Tornos Swiss machines in here turning these things out. But
The size of this room.
yeah, especially one of their big. In fact, Lehigh I think has one of their big multi-Swiss guys made. I think it might be a Tornos. I'm not sure. But yeah,
How much are those? Several hundred thousand?
Oh, millions.
No,
the
millions.
multi-spindle are
Excuse me, I'm
millions.
not a machinist. Excuse
So,
me.
yeah, that's it's like I said. Ultimately, it's just an industrial scale production lathe is what we're turning these on. And I'll see if I can figure out which machine it is and drop it in the chat. But another question was, let's see, about making the Dagger on the Ghost Gunner 3. And actually, that's something we've been very busy with lately. What do we got
He's
going?
gonna go get something. He's not just leaving,
Yeah.
I promise.
Yeah, so this is something we've been working on. The run out, I think, was that the TIR was a little higher than we wanted, or did we find that wasn't
just
so
bring the
bad?
whole
A
thing
lot
over.
higher. It's 3
Yeah.
times higher
Yeah,
than
yeah.
the manual cost.
The total indicated run out that we were measuring on the Ghost Gunner 3 that we have is three times higher than what was spec'd. And that's going to be a problem.
I don't know if you guys can see this, but there's a.
Yeah.
Do you see a
Yeah,
jig
okay.
in there? A little bit.
Yeah, the white thing.
I don't know if we try some lighting changes here. Try that.
Rotate it so you guys can see the upper side of it. Those two little, those are just aluminum as an analog, but that's our jig, and that just to show you that I'm actively working on it.
So that's there's been a couple of strategies to take on this. Is are we going to use the Ghost Gunner like a lathe? The original thought was we'd come up with kind of a lathe conversions where you'd put your workpiece in the spindle and then mount tools on the deck. But I'm not sure if that's going to work. So we're now also kind of working on a way to do this as a milling operation. So that's something else that we've got in the works. We're still working on it. We haven't given up on it.
Because I assume most of if everybody online is donors and they know this already, but something else that you've been working on in the past year or so while you've been switching to injection molding is you had to design a completely new machine too to make the injection molded jackets able to be used. So that was a completely unexpected detour.
Yeah, talking, again, the Jonathan's solo pencil making problem with explosives. The jackets, the way we make them, a lot of these guys, the standard way to make an injection molded part, especially something like this, with different thickness sections and segments, is you want to inject the plastic in the thickest part of the part and then let it fill out from there. But our concern with that is that might create suture lines on the other side of the jacket that could be induced weaknesses, and maybe you end up with some asymmetries, right? That aren't really what you want in a bullet. It should be very symmetrical. So one of our requirements is that, and you can kind of see that little white dot in the middle. That's the vestige that's left over from molding these. The valve gate sits right there behind the floor of the jacket and injects into that. And the gate system that we use is actually really good at getting rid of that vestige as much as you can. But there's like to the point where we're actually pressing the gate, that little vestige, into the part during the closure sequence during the molding cycle, and but it's still there to the tune of a few thousandths of an inch, which means that if you were to set this jacket on a flat surface,
as our assembly machine.
Yes, like the assembly machine we're using to put these together, it would be slightly tilted. And when we have a liquid adhesive in there, we don't want that, because again, you're creating asymmetries, and that's just not a good thing in a bullet. So we've had to, and switching to injection molding has been a nightmare from that standpoint, from the just general injection molding standpoint, but also because we've had to design a whole additional machine to trim off that little vestige. And I know Austin's referenced it before, but Dillon Precision shouldn't be called Dillon Precision or have micrometers in their logo, because there is nothing precise about a Dillon XL650, let me tell you. So
they also have taken in the trim dies that we were using to do this, because the 650 with the automation package added onto it is what a lot of people use to trim brass down to size. In fact, they use it to like convert 556 brass to a 300 blackout, and so that's what we were thinking. We would trim the vestige with that, retrofit the machine, and that would be our trimmer. So we're using the trim die that goes with that. And for their trim die, they used a 13/16/20 thread. So that is a dimension, a major diameter that is completely non-standard. It's not standardized or defined. And if it were, it's an extra fine thread. So it is truly hell. It doesn't belong.
So I don't know if we have any of those dies laying around.
We had to custom order the die.
Yeah, we've been using SLA printing. Apparently we're on Formlabs high throughput user group now, because that we have a Form 3 that probably runs 50 to 60% of the time almost. I mean, at times it's running almost continuously for stretches here. And this was an early iteration of the custom stage that we were developing for this trimming operation. It has evolved far beyond this. This thing just looks weird.
Yeah, actually.
Sorry if it's washed out, but
didn't even recognize that one.
Yeah, this is, I think, the very first one that I made for it. And, but there's when you push these kind of limits, even with printing, because we're chasing like thousandths of an inch with 3D printing, and we even find that like this surface, which is apparently flat, is actually not. There's a little bit of a warp to it, and it's isotropic, right? Like or was that right? It's in one dimension, if you will, more than another, and so it changes. When the turret would turn, the jacket would be centered under the trimming station, but under the station that has to remove it from the machine, it is not centered, and that can be a problem. So this is now, I guess we was that this week we talked to a machine shop, and they're going to make
we
machining.
Jake over at JWC Arms or whatever, he makes a bunch of he makes like Mac bolts and uppers and the rails for 3D printed guns and stuff. We like him. He does really good work for us.
Yeah.
He's reasonable. He's a friendly guy. So
yeah, fair.
He's making that right now.
So let's see what else here. Can a hand loader assemble them? That's the idea. In the long run, or like really the midterm run here, we already have cores up on the website.
Here, hold on. I'll say this. If you guys like reading this, I didn't even think about it. Like some of you guys may not have seen the manual, but if you haven't seen the manual, it make a lot more sense, this stuff, if you went to see it. It's go to atlasarms.org and then scroll down on the page, and there will be buttons in black and white for the manual and the patent. So you can see both of those. If you click on the manual, originally, so like we are legally disallowed from distributing that ourselves, but someone posted it on Odyssey, so we were able to link to his post, which he did anonymously, and we did not ask him to do that, but he did, and so now you guys can see it for free on that Odyssey post.
So obviously, this page, it's to buy a jump drive. You don't have to buy the jump drive. If you just scroll down in the description, you'll see a line with a link to Odyssey. You click that, and you can go download the package there.
You can buy the jump drive.
You can buy the jump drive if you want. It goes to Atlas Arms Research, but yeah. So that's right. Good karma for everyone who buys it. That's the price of it, just a jump drive. How nice. And then regarding 3D printing, with in particular the jackets, that's actually what initially brought me into the project, was 3D printing the jackets. And we've learned a lot. We haven't even tested anything yet because we've been chasing the tolerances. And we've done, I don't know how many, I've probably printed 300 jackets at this point, maybe more than that.
As many as I've machined by hand.
Yeah. And measured as many. And the thing with printing, right now, and this is using initially a Form 2 and now a Form 3 SLA printer. These SLA printers are really good for detail, and they are very precise. But you will still get some skew. And one of the things that's important is that these jackets need to be very concentric. So what we're doing, one of the things we did is kind of printed a map of jackets on the build platform of the Form 3, and then measure and come up with the distribution for how the skew happens. And then you could, in theory, go into CAD and make the adjustments to the model for each position, and but that's really tough. So actually, the route that we're working on, or will be back to working on here shortly, is trying to print one jacket at a time in the dead center of the build platform every single time. So you print 1 or 2 or 3 or whatever, and you'll measure the bearing surface, you measure the heights, you'll have to make some compensations for this kind of elephant's foot that you get at the base, because we're not printing it on supports. And then you reprint, and then you measure, and then you adjust, and you reprint, and you could go through this iterative process several times. And the hope is that in the end you end up with something that, okay, this is good enough to use.
And once you get it, you can print that again and again and again and again.
But the key is, what we found is, if you move that jacket from one spot on the build platform to a different one,
throws off all your compensations.
It throws your compensations off, and that's been tough. In fact, in some of our other projects here, I don't know why Formlabs with their slicing software Preform doesn't give you a way to just move your part to the geometric center of the to move the geometric center of your part to the center of the build platform. So we've had to actually add features that force Preform to put it in the center to kind of do that. But is it possible to turn the prints on a cheap lathe for concentricity? Probably not, because runout is an issue even on.
It'd also be hard to chuck onto it.
Yeah,
just right. And that's another thing that's like, you know what? If it's okay, let me go back to telling the story.
Yeah, sure.
Because a lot of this is exposed just by hearing what we've gone through to this end. So, like, I guess to go back to it, we're in Arizona. We start using this lathe, and we start making great prototypes.
In the bedroom of the second-story, 2-bedroom apartment.
Right. And we in the Ultim jackets, they just weren't working. No matter what we did, we found out that when we did experiments, like our own careful experiments and investigation,
because no one else had, so we had to do our own adhesive experiments too.
Completely different odds. It was at odds with the official documentation that the adhesives companies would provide in their data sheet on adhesion with Ultim. But even more than that, Ultim isn't documented. It's kind of a rarer plastic, so there's not documentation on it. Yeah, polyetheramide, PEI is its true name's chemical name. So we started using polycarbonate, and it worked. And it didn't just work; it worked extremely well, and it did even better at expanding and wounding than the Ultim did, which was quite a surprise. And then finally, when we started getting ones that would consistently work every time, we wanted to test them on armor. But to set the stage, this was in 2020. And if you guys don't remember, the firearms industry in 2020 was insane because of COVID and because of all the riots that were going on. That was when ammunition, you just couldn't find it on the shelves anywhere. You couldn't even get primers to reload. And the lead time on armor was insane. I mean, we ordered, so this is the first panel. This is the panel we shot for the demonstration video. And we ordered it. It had, was it 6 or 8 week lead time?
6 to 8, I think. Yeah. So I think
crazy long lead time, and it's not cheap. Armor really isn't cheap. And remember, we still can't get any money out of the crowdfunding side at this time. Or we can, but it's pulling teeth, and we don't have much. So we ordered this, and well, we got to save this to use for the video demonstration. So Vin Win, I don't know if you guys know him, but he was really big in the printed gun space a while ago. A friend of ours, he found this one, which is of a lower quality than the AR500 Hybrid 3A. Found that one in a store in Atlanta and bought it for us and shipped it. So this is the first panel that we ever penetrated, and since then we've used it for testing, so you can see all those on it.
It's not like we had a whole bunch lying around.
Right. So we tested on this. This worked, and it is the happiest day of the last year.
So you can see all this.
And so immediately we started planning the penetration demo video. And, we're trying to be professional as possible. We did a really good professional on the ball crowdfunding video, and the same one. We've been working on this for, what was it, a year and a half at this point. We decided, look, we got to do this professionally. We got to show people professionally and really well, beyond a shadow of a doubt, that when they see me, they see the bullet, they see go into the magazine, into the gun, I rack the gun, I shoot it. They're seeing this from 2 different angles. I wanted to make sure that people knew very professionally, this is a real thing at this point, and it works. So, that was, and Patrick, who's been commenting here, he came down with Kelby and Kaysen, who shot the penetration video. And man, I was ecstatic that day. That was the best day I had in at least a year. I mean, I was on top of the world that day, being able, because again, we only shot this one, and this is a better armor than this one is, and we didn't know at the time what it was capable of. And of course, it's funny in retrospect, when we were about to leave Arizona, we finally had the time to go and shoot this stuff. This is made by UARM, a Ukrainian armor company. I mean, funny now because of the war in Ukraine that wasn't happening then. But it's level 3A+, and it is rated to stop steel core 7.62 Tokarev. So 7.62 Tokarev, just the regular 7.62 Tokarev can go through 3A, like normal 3A body armor. So steel core is great at defeating pistol level body armor, and this stuff can stop it, and we shot through it. So on that day we shot through, these were the day we tested it. And this is when Michael shot through it with a sub, I don't know if you can see it, with a subcompact pocket pistol, right?
Well, not quite. It's a 3.7 inch barrel, I think.
Whatever. We didn't have a backer behind it, which means that it was actually harder to get through this because it deforms all that material instead of penetrating clean. But it went through it. So it turns out, really, really sure. Apparently that day when we shot that penetration demo video, we could have gone through this. We could have gone through the best pistol rated armor, and we just didn't know. So for the longest time, we've had people saying, yeah, but like civil defense can go through that too. Yeah, it can. It can barely, under the right circumstances, go through this stuff. But it has a snowball's chance in hell of going through that.
Oh yeah, and by the way, it's also way higher pressure than what ours does going through.
There is that too. So I think, and I'll stop and answer this question. We got an email question. Can you read that email question that we got?
Which one?
About how we like the success or the lack thereof.
Let me go back and switch into the right account.
While he's doing that, even just another facet of how deep down the rabbit hole we went for everything was even just the clay backer for the armor. So if you read like the NIJ document and whatnot, there's this Roma plastilina clay, and we were wanting to make sure we used the right clay because we didn't want anybody to tell us, oh, well, you didn't do it right because you used the wrong clay or whatever. So we found Roma plastilina, and it was so much more expensive than other clays. I mean, just absurdly expensive. It was going to be like $1,000, I think, in clay to fill our frame, or just something ridiculous. And so I read through the NIJ's document, and it turns out that the clay that they used to originally set it all up was back in like the 70s, and that clay doesn't actually exist anymore. And so now when they test armor, they use clay that's similar, that they heat up or cool down
to like 100 and something degrees.
Yeah, to try to approximate what the clay used to be. So it turns out that ballistic clay is not actually its own thing now. So just another facet of diving down the rabbit hole to make sure that we crossed our T's and dotted all our I's was figuring out what exact clay was okay to use for the backers of this.
What's that?
Okay.
What's that question?
This is how have you enjoyed this project's journey and success?
Yeah. Who asked
This was from Elite. Well, I don't know if we want to say.
Oh yeah, may not want to say his name. No, that's true.
Anyways,
but you know how you are.
Yeah, you know who you are if you asked it. It's how have you enjoyed this project's journey and success, or lack thereof? Is there anything you learned that would make a second similar project more efficient?
This is a very deep question and a very good one. The first sentence, how have you enjoyed the success or lack thereof? Again, at the very beginning of this, I wasn't 100% sure it would work. And if you read that manual, it talks about the design criteria that we used. And I thought that we would get something that would penetrate normal 3A armor at least more reliably, than civil defense and some of the other like solid copper 9mm stuff. Like civil defense can 80 grain Fort Scott munitions 9mm can penetrate this stuff under perfect conditions with like a full length barrel, but it can't with a compact barrel or whatever. And I thought we'll just do it that way, but at least we can do that. At least we can be better at penetrating 3A. I thought more was possible, but I wasn't sure. So that we can penetrate this with a copper core, mind you, and should be able.
In a pistol.
I say should be able because, well, unfortunately, we can't talk much about the present state of the actual Dagny Dagger with an MP35N core. We're limited in what we will say about it. And if you're wondering why, go check out the Texas state ban on armor-piercing ammunition, and maybe that'll give you a little bit of an idea. But this hole right here in this was left by the copper core. What was an Eddie Everyman? Okay, you can see on the back. I don't know if you can see that. There's a bit of deformation. It did not go through clearly. But that hole is most of the way through that plate. So
And that is what level 7?
That is level 3 rifle plate. So with like the actual dagger, I think you get the picture. So so like I'm very happy with that. Also, we decided like one of the criteria was we got to make this thing perform. Like we got to make its wounding capability better than a standard hollow point. Because like, so what if because the whole point of this project, right? I mean, yeah, there's the point of the project itself, the purposes, the aims of federally legal armor penetration and all of that. But it's also, again, the idea that we're trying to springboard more interesting and even more impactful projects on this that we need funding for. So it needs to be commercializable. And, so what if you can break through armor? Nobody's going to buy that, right? Like, do you want to?
Yeah, how often are you going to deal with that, right?
The guy breaking into your house, he might be armored. And these days, that is a real possibility. Yeah. But you probably want to be more sure that it's going to make a massive hole in his stomach than you are that it'll go through any body armor that he may or may not be wearing. So if we didn't have better terminal performance than Full Metal Jacket, round nose 9mm, what's the point? We're hardly going to sell any. I thought that we would just be able to do a little better than that, maybe on the level of some of those screwdriver looking bullets that you see, which aren't actually they're better than round nose, but they're not great. But it turns out, no, we can, ours probably has, I think that it is fair to say that we objectively exhibit better wounding than any other 9mm on the market. I really believe that. And so
we know that from shooting numerous gel blocks, ballistics gel.
I couldn't be any more happy with the technical success of the project. I mean, you go to the manual and you read that list of superlatives. It's the highest this and this and this and this, and it's the lowest this and this and this. And I can't believe that. I'm very grateful for the level of success that we've had technically. Now, this project has been very, on a dark side, this project has been very, very painful for me. And I was starting to get there with our kind of like walk through the history of the project. I'm very cut out to be a design engineer. I'm not cut out to grind on a lathe all day for a single run of prototypes. In the early days we do 6, and then we started doing 12 prototypes at a time. And that was I say it's like it's almost literally a back-breaking process, because I'd sit there and the process of making one jacket is like 6 minutes or something like that, and I'd have to sit there with the water dropper, because our lathe, again, it's cheap, it's what we could afford.
Well, it's not so much that it's we didn't have a coolant set up with it, right? It's in a bedroom in an apartment. It's not like we can have coolant spraying everywhere. There's carpet. Right. We're renting, so we can't just have this machine shop set up. So that'd be very controlled.
So I'm sitting there dropping water on it very carefully, making one, and then it comes off, and then we have to sit there with the micrometers. And this is another aspect, right? We'd sit there. A big challenge, probably the biggest challenge of the development, was figuring out how to measure these things. I can't afford a comparator. I can't afford an optical measuring instrument.
And we talked to General Inspection, so I'm sure those y'all on Twitter have seen Phoenix's posts about their inspection equipment, which is really nice equipment. And we talked to that company, and they make something called the Vision Lab, which is just a desk-sized thing. You can place your object on a stage and get an idea of what the dimensions are on it. And that thing alone was $45,000 or $50,000. So we're like, well, we'll just stick to doing it by hand. But fortunately, they actually measured one for us, and it turns out that the way we've been measuring it has actually been right on. Which
is amazing. I mean, because it's a thin,
Jack.
We got to measure that to a tenth of a thousandth of an inch, right? For the purposes of development. Now, the actual tolerances aren't quite that tight. Now we know, but for the purpose of like you were asking, compressing the load, right? Well, how much did this bullet perform differently than this one because we made the ogive different, or because it was slightly different in terms of
Cartridge OEL.
yeah, or, cartridge OEL, or because of the bearing diameter, right? You got to measure really, really tight to know that stuff just to develop it. But these things, like, do you have a jacket out still? Don't worry about it. Like the walls, the walls on these jackets are so thin. I mean, it's just plastic. So you put the micrometer on that, you squeeze the micrometer on the sides of that, and it deforms. It just does. And without an optical
flexes. That's a temporary definition.
Well, yeah. But like, trying to figure out how to do that very, very consistently. Like you can't even have ratchet thimble micrometers, and we had to have measuring the inside diameter was even worse, because like when you're measuring the inside diameter,
then you're
you tend to just
outward.
Where the wall thickness is the thinnest is very, very difficult to measure those. And when again we take 9 measurements every time, and I'd be sitting over the desk, very, very careful with the micrometers.
Machine one, and then you have to sit at the desk to measure it to make sure the measurements came out right.
And you have to clean it and deburr it before measuring. And when I say it's like almost literally back-breaking, my back hurt after a full day of that. And it would take a full day to get a batch of 12.
Oh, we very rarely made 12 in one day. 12 good ones in
and
one
I'll
day.
say, like,
only on good days did we actually get 12 jackets that were good in one day. And
that's
that was
true.
Working as long as we possibly could and going up into the temperature changing in the room too much because of the sun rising or going down to continue.
Yeah.
So very rarely do we actually get all 12 in one day.
And I made most of them, but I will give Lauren a lot of credit because she helped me measure, and she did turn some cores and jackets, sit there with the acid brush with cutting oil for the cores and the water for the jackets. But that was really, really hard on me, and just how my brain works. I was in a very, very deep, despairing depression for a long time. It got really, really dark, and I can't believe that I made it through that chapter. And to this day, when you say like the lack of success thereof, maybe, I am still not entirely sure if it was a wise thing to do to start on this project. Not that it hasn't been successful, again, wildly so, but man, it took a lot out of me, and I've been really worried that my carefree and positive and playful, creative personality might not make it out. And Lauren says that it is these
Getting
days.
Back. Only recently.
but it was pretty tough. So, going with that to the second sentence of your question, doing it over again, there's not much that we can improve except because we didn't have any money. I mean, we've been shoestringing the whole way, right? Like, if I wasn't a very, very frugal person, really good at figuring out contingencies and making do, we wouldn't have made it this far. More money would have helped it be a lot easier, a lot less painful, a lot faster, but we just haven't had it. But yeah, doing it over again, I would have to think long and hard about if I actually wanted to. So there you go. That is
in addition to the money thing. So before Michael joined in, I was doing most of the business side. So I made the website. So if you don't like it, that's too bad. So I was handling most of the business side because I'm not an engineer and I'm not a machinist either. On top of working on a PhD. And
tell them what it's in, because that's one of the questions.
My PhD was in, let's see, the title was Near Infrared Characterization of Near Earth Asteroids. But to make it sound cooler, I find water on asteroids. So, there you go. So that's what I do with the rest of my time. But yeah, so I was handling the business side, which is just awful. So in addition to the money thing, also having Michael on board to take care of the business side, even though he's much more on the Atlas Arms manufacturing than the Atlas Arms research side, has been a wonderful boon. So that's the other thing.
That's another thing I'm very grateful for is to be honest, like Michael again, like he reached out to me a long time ago. He's like, I think the jackets can be 3D printed, and he had an SLA printer, and he started trying. And it was at the first Guns and Bitcoin conference that I gave a talk. and Michael liked a lot of what I had to say, and well, I shouldn't.
We were
talk
actually
for
staying
you.
in the same house. We had the big,
Yeah.
We never met in
the
person.
deterrence dispense house.
Yeah.
For the OG guys. I'm sure maybe there's some of y'all here. I don't know. But yeah, a bunch of I guess the original admins and guys from Deterrence Dispense shared a house at the First Guns of Bitcoin. I brought the 3D printer. We actually worked on it all while we were at the conference. But yeah, and then I suppose for me, I got COVID laid off. I'm a geologist by training and trade originally, and when we had no more rigs running, they were like, "Well, why do we need a geologist?" So, see ya. And I was like, "Well, I don't really want to be in oil and gas anymore." So I reached out to Austin because it looked like Atlas Arms researcher Austin was kind of on the verge of actually needing some help, on the commercial side. So I actually sold my house and moved my family here to Kerrville, and put the money from the house into the company. And they came down. Actually, we're pretty fortunate that we have some family land here, and we're able to set up in another house on the land. So that's been kind of the adventure. So big changes for all of us, but yeah.
Yeah. Speaking of one of those big changes, we have a 7-month-old daughter, and I have to go put her to bed. So yeah. So it was nice chatting with everybody, but I need to go.
Thanks for being here.
Yeah. So see you all later.
There was one question. Did you put any proposals for web time since off-breaks?
Actually, yes, I did. I put in a proposal for both the first cycle and the second cycle. Unfortunately, I didn't get time for either proposal. However, I did make it into the third quintile. So I did a lot better than a lot of my peers. So basically, the first and second quintiles and some of the third all got time. So I just barely missed out.
It's mostly because they're more interested in outside the solar system targets.
Yeah. So I don't want to take it away from what the point of this is. I could go on all the time, but anyway. Something like 94% of the telescope time is on extra solar system targets, so galaxies, stars, that sort of thing. So that means only 6% goes to solar system targets. And missions that are already funded by NASA got preference, as well as Mars. Who, anyway. so very, very, very little of the time for James Webb actually is on solar system stuff. Yeah. But one of these times I'll get it. So anyway, all right. Good night, all.
I'm going to work back on a few questions here.
Yeah. Well, hold on. There's someone I would say, like, particularly, I'm very grateful to have found Michael. I've been in the startup world before, and startup culture is the most toxic I've ever experienced. Where like half of everyone's a psychopath and everyone's just looking for a way to screw each other, and they're just lying all the time. And Michael gets it. And I don't have to keep looking over my shoulder at like, well, how's he gonna screw me next? I gotta so much of the time, like productive people have to cover themselves from, the administrators or the money guys or whatever. And not that Michael is just that. I mean, he does a lot of technical stuff around here, but I'm very grateful that I found a business partner that I don't have to worry about and that I know is here and with me. And it's a really rare thing. So
I will say, if that's something, if anybody's starting a business or doing anything like that, if you can find someone who can, balance your strengths and weaknesses, right? Like I'm a geologist. I have some technical ability and everything, but I'm not the engineering guy here. And, but Austin's not the guy to deal with ATF, which is one of the questions here, or deal with all the accounting and business, BS that we have to go through, and software for our ERP package and everything. It's just a mess. But to address that, by the way, ATF, how's ATF been treating us? Actually, not that bad. I think part of it's because I don't want to dick with them too much until I have enough money to defend myself in court. But we had no issues. We have a type 10 FFL and we've got our SOT and all of that. We don't have the FEL because we don't have a good place to put the really fun, serious Play-Doh or serious putty. But the ATF hasn't been that bad so far. I mean, I actually did get a call from them last week. They were looking for an FFL in Texas that apparently sold a 50 cal. We haven't sold any guns, so it's not really an issue for us. But we've got a couple other projects kind of in the loop, and I suppose we can kind of touch on at least one of the funny things with this is armor piercing ammunition in part is defined. Part of the requirement is that the cartridge may be used in a handgun. So the question is like, okay, well, what does that mean? May be used in a handgun. So we actually obviously they say, you can go through, they've got a big document that's 20 pages long that you can kind of read through to get an idea. But it still is kind of gray. And so I asked the Fat D guys, like, hey, can you give me a list of cartridges that may be used in a handgun? And they're like, oh, we don't have a list. So, which really means basically like we don't have a list, but if you make something that may be used in a handgun and it's armor piercing under the law, we're going to come fuck you. So, so we're putting together a list of stuff to see if they'll get determinations on, and at some point in the future we'll send that to them and harass them a bit more. But we had more issues actually with gun companies when we were looking for machine shops. There was one, they make receivers and stuff for Wilson Combat. And or are they Tennessee? Do you remember?
No, they're here.
Were they?
Well, in the Houston area.
Were they? Well, this machine shop, was interested at first, and they're like, well, hey, can you send me your IOI's information? I want to talk to them about your project. And I'm like, no. I mean, I'm not worried about it, but I don't really think we should be poking them right now because we can't afford to defend ourselves yet. So, that's been our ATF experience so far, and they've actually not been that bad. They're kind of, not yet at least, but I suspect that when we get this stuff into commercial production, they'll be a little more interested in us.
We mind our P's and Q's, and we dot our I's and cross our T's, and the safe back here is mandated. We have to store the armor piercing ammunition in there, and we've got special doors, and they got no reason. But
is that a song that got no reason? Short people and the ATF both have no reason. One of the other questions, sorry, just kind of want to hit these so people, if they want to jet, they can. But there was, you guys famously don't like 45 ACP, but would large bores take to a Sabo-like design as well? Yeah,
they would. They would.
The key with the big thing for 45 ACP is it's fairly low pressure.
Remember, it's not a Sabo. I mean, I get what you're saying.
And it's not.
But I just don't want other people to hear that and think, oh, it's just,
it's not a Sabo.
Not a Sabo.
It's the jacket and the core stay together in flight. There was another one, JD Hill. We emailed back and forth about the Dagger and a cartridge called the VBR Paralight a few months ago. Thoughts on the viability of a two-piece discarding puller Sabo to launch a solid 224 projectile?
Discarding to launch a 224. I mean, I guess it could be done. I would rather just a tip. Like, why use 224? Like if you're gonna make a Sabo, just like you should make the penetrator. You should make the penetrator its own thing, right? Just like. We don't have like a solid copper 22 caliber bullet as the core for our Dagger. We made it work in unison. It's the same thing. Like, why make it 22 caliber? You can make it, why put a bullet in there? Just make it a penetrator, or make it a projectile that is unique to that particular loading and will be optimized to function in that particular loading. So, I don't know. My thoughts, it's just like any Sabo, it'll make things go faster. But if I were to do it, it wouldn't be a 223 penetrator because that just limits your performance. We can do something custom, something optimized. So, if you want to email us about it, I'm happy to go into that more in email. So,
let's Let's see. Did I do any oil and gas work in Wyoming? No, I did some field work with a Nautilus class, but that was a long time ago. Powder River Basin stuff. But
we're jumping around a lot here, and sorry.
I just want to hit these so I don't lose track because things are feeding a little quicker. Let's see. Michael Colano asks, how bad of an idea would it be to use the Dagger for hunting small game, say fox-sized or lower? Obviously, it wouldn't be good for moose.
No. Fox size and that's great. It would excel. It would be very good at that.
We actually have, there's 3 variants. There's the MP35N, that's the Dagny Dagger, the exotic alloy version. We have the Eddie Everyman, which uses a harder copper alloy, and then we have the Piggy Popper, which is a softer copper alloy, and that's actually intended for hunting, pigs and small game like that. Or we're in Texas, right? So you could maybe go shoot pigs with a 9mm PCC, and then your sidearm and your PCC both use the same ammo.
If you're hog dogging and don't want to use the knife, then you got the pistol, right?
Yeah, that's an experience. If you've never been hog dogging, well, I'm sure there's a dirtier interpretation to that too. That's the idea of the Piggy Popper is actually for like shooting, pigs and nuisance game. And you of course got to watch for whatever your state rules are with regards to hunting. Although it doesn't matter if you're not hunting a game animal, usually.
Pigs are invasive.
But pigs are invasive. They're not a game animal. You can use tannerite on them. You could use shotguns or,
or helicopters.
Helicopters, right. Come down to Texas for a helicopter. Let's see. Are you ready for the coming heel turn when the ATF decides they want to take you on? Many horror stories of the ATF being cool with something and then deciding they want to end you. And yes, we kind of anticipate that. Can you actually be ready for that? I think the answer is no.
But let me tell you about our lawyer, because you may have seen our lawyer in congressional hearings.
Yes.
Prominently featured. Matt is a great lawyer.
Yeah.
But look, that's been when we first announced this project publicly. I had Boomer Fuds. Like every email was just another Boomer Fud telling me like, well, it may technically be legal, but the feds actually say it's illegal, and you're going to go to prison. You're going to go to prison. They're going to hammer you. And I carried a knot in my stomach, thinking like, yeah, I guess apparently I'm going to prison now. I don't know. So, we face that. Like, this isn't new, right? Like this is kind of like the nature of the project. But look, you hear the stories of the midnight raids, like something is perfectly fine, and then Biden directs Merrick Garland to direct Dettelbach to put the hammer down on somebody or whatever, and it always comes like we're not concerned about the institution. We're concerned about the top brass, the politicized ones who are controlling the institution. Like if the midnight raid comes, then the midnight raid comes, and we're out of business. And that's the worst case, right? Like we could fight it. We could fight it very well, especially if we're in production, as long as the powers that be in the gun industry, like the FBC and the GOA and the Second Amendment Foundation, all those want to side with us, then we'll be ready for a fight. Even if we don't fight it off, okay, Atlas Arms goes away. And we take all the money that we've made from Atlas Arms and we make Fountainhead Firearms instead. And we start doing all the projects that we wanted to get to anyway.
And never mind now the Dagger's in public domain effectively.
It's done. They can't take it away.
Go DIY it. The bullet's here forever. And hopefully with, some Ghost Gunner code or whatever in printing, we can make it easier to make them. But it's done. That was the whole goal, was to, you couldn't spend the amount that we put into the project to undo a federal law through lobbying. We did it with design. So, I anticipate they'll get mad at us, but it is what it is. And you kind of got to, draw your line in the sand, right? So, if it happens, it happens.
And I'll say this too, one of the hats I wear is like legal strategy. And this stuff has been thought out again and again and again. like we don't want to talk about it because, if we did, we'd kind of give up our, we don't want to show our hand, right? But we spend a lot of resources, and one of the difficult things about this is not just exploiting, the present circumstance, but making sure that it stays legal. That is a lot of our effort, and has been a lot of our effort is that legal strategy and making sure that we're safe. For instance, I don't think it's too much of a tip of hand. Is that look at the definition of armor-piercing ammunition. Like, what are they going to do? Well, yeah, Congress, it would take another whole act of Congress. Congress would have to say, we're going to ban this particular type of ammunition.
Which they did. They did in 94.
They did.
But that's what it takes.
That was part of the assault weapons ban. Yeah. That's a big deal, guys. So, if Congress decides to shut us out again, I guess
I'd be kind of proud if we motivated an act of Congress. I drink to that. But
people then say well, yeah, but the ATF does whatever it wants. Well, even the ATF is still
no dogs.
With even the machine gun, even the bump stock ban. Yeah. They're oh no, it's not a machine gun. Even that played out okay in the end, right? Or they say, even if that did succeed, well, okay, that's a lot closer. A bump stock's a lot closer to being a machine gun than our bullet is to having, brass, beryllium, copper, tungsten, steel, bronze, depleted uranium, right? It's not. It's just not. MP35N is not at a definitional level. Absolutely none of those, and neither is copper. So, there's no room for. And if they also,
there's no ambiguity in this one for us.
The easiest way for Congress to ban our stuff would just to say, oh well, nothing with no copper projectiles or cores. Well, then we've drawn in Lehigh and Barnes and all those other ammunition companies into the fight, and that has some serious NSSF and NRA. Money behind it, let alone the real gun rights organization. So we feel pretty safe on that. Yeah. We really do.
Yeah. Other questions were, what's the maximum penetration? This is from Hummer's Sick Ass. Hummer's Kick Ass. Sorry. Hummer's Sick Ass. Sorry. What's the maximum penetration you're planning for pistol-based Dagger rounds, and what is the max pen plan for rifle rounds? Sorry if already answered. Just got here.
Oh, glad to have you if you just got here. The maximum with a pistol, this gets a little hard because this requires us to look into this is so 9mm, it's that level 3 rifle plate. Okay. With the copper core 9mm, it's this stuff, and publicly you can see public videos of us shooting through that with ease. If you go up to bigger pistols, we're going to do a 10mm someday. Pretty shortly after commercialization, we're going to do a 350 SIG and 357 SIG and 9x25 Dillon. Those might take it to another level. A 10mm proper Dagger will probably get through level 3+. So not this, but maybe also the step above it. We'll just have to see about that. Rifle, the 5.56 will get through level 3+. Absolutely, it may be able to get through very poorly constructed level 4, but not reliably. However, we do have a project to use a rifle-only caliber to put a tungsten core in, similar to the way we use copper and MP35 in with the Dagger project, and that will absolutely go through any level 4 that has ever existed. It'll blast it all away. So, that question is hard to answer really particularly, but feel free to email us or put it in the comments of this video. I'm sure at some point I'll read the comments and I'll answer any questions down there.
Let's see what else we had. Albert 9x19. It's good to see you here.
Yeah, we're okay. I'll say Albert because Lauren used to man the UR, and so we hadn't been able for a long time, or she used to help me with pressure testing. So we hadn't been able to pressure test your homemade powder there.
It's literally on the bench.
Yeah, but like on my imminent to-do list is to test this. So Michael's going to take Lauren's place, and we'll get it tested in the next several weeks. So
Albert asks, NAS3 cases were a part of the development, if I recall correctly. Is that still the case? Has there been any testing with once fired brass 9mm cases?
There has not been any testing with the brass cases. The next revision of the manual, we'll test with brass. The issue with that, if you weren't here in the very beginning of the video, is that we have to send our sensor and some brass off to be calibrated, and the barrel, the UR barrel also, to be calibrated by PCB for every new type of brass that we use. So like we would have to get Starline calibrated if we were using Starline. We'd have to get Winchester calibrated if we were using Winchester. So it's a lot easier for us just to say, okay, look, just give us a calibration curve for NAS3. So we're going to have to send off to have those brass cases made. It will work in the brass. It's just a matter of pressure testing and making sure that we're getting the right pressure, because NAS3 has a higher case capacity. So if you cram the same amount of powder into a brass case, it's going to be a higher pressure, which is no good, especially when we're already in the +P+ range.
Playmaker 2007, any thoughts towards wire EDM for high precision machining of the Dagger? And the answer would be no, because we cannot commercially use wire EDM to make the volumes that we would need.
Yeah,
you could get some really nice stuff though, I'm sure.
So in terms of the volume, guys, our assembly machine will make 2,000 bullets every hour. And if you crunch that, it's something like 3 million a year. If we run it 8 days a week, 8 hours a day, 5 days a week, 52 weeks a year. That is so much volume that even high volume Swiss machine shops are having trouble keeping up with it, or screw machine shops are having trouble keeping up with it on machines that were designed to make screws, which are, the ultimate in high volume parts. So you'd have to have 1,000 wire EDM machines to keep up with their volume.
Yeah, I mean the first order, for those who don't know, I mean the initial order that we've got in for cores, and as an example, all the material we have it's actually at the machine shop. We're making about 100,000 rounds for the first batch, and of course the same. Obviously, there's going to be a jacket for every core, we hope. So that's we'll churn through that pretty quickly, and that's hopefully going to fund the next batch. But yeah, you just can't do the volume with something like that. Let's see.
If you can answer some, I'm gonna get some water.
Yeah, okay. If I can't get any of the alloys needed for the projectiles, is clay an acceptable substitute? And I think the answer to that would be no. But try it. I'd be curious to see what you come up with. Let's see. Any thoughts on the arrest of Matt from CRS Firearms? As I understand it, like in that case, ATF had a machinist actually try that auto key card out, right? That's what this one is, if I remember correctly. And he had to modify it beyond what the auto key card cutouts actually had to get it to work. So I'm astounded that they got a conviction on that, which is, I mean, that was messed up. I'm not a fan. GG code for cores or for jackets would be nice. Yes, I agree. And I know that's one of the things we're working on. In fact, if you weren't here earlier, Austin had pulled the Ghost Gunner out and, it was a little washed out, but tried to show the jig that we're working on for it. And of course, with that comes code. If I can get the molded jackets working half decently, we might be able to have vendors sell nicely machined molds too. Yeah, Photon. Yeah, I mean that I'd like to see that work out.
Photon's been working on at-home molding of the jackets.
Yeah, I've seen it. That white.
If he can do it, that's quite a feat.
That'd be pretty cool. I'd love to see that, man. I mean, that'd be fantastic. The easier it is, like we're able to do this commercially because the reality is most people don't have the means or the skills or the desire to spend the time to make a magazine full of daggers or whatever version of the dagger they choose to make. So we're not really, that's why we're comfortable. I mean, obviously the goal was to put it out in public, but like the easier it is, I think the better for people to DIY these. I think it's fantastic. So keep going. What else here? Don't keep a dog at your licensed premises. I've got 2 next door. But Photon, I do think they stomp cats, so be careful. Let's see. These projectiles were designed for hard material penetration, but it seems to do very well in soft material. How much of that was expected or a surprise? The sabot seems to act like a hollow point. Okay, not a sabot. The jacket and the core stay together in flight. The actual designation for the dagger is an APHP, armor penetrating hollow point, which is like a contradiction in terms for most, but here it's kind of actually does work that way. The idea, and this was a big part of the project, was finding the right adhesive to bond the core to the jacket, because you didn't want it to be too strong, because you don't want to waste energy dragging the jacket through armor. You want it to separate, and but you also need it to be strong enough to stay together through being fired.
Yeah. That took a lot of, that was a lot of our optimization, is testing different adhesives for which one of them, number one, worked in the bullet. So like this, if you again just read the manual and you'll see how complicated some of the adhesive dynamics are when you actually assemble the bullet, which took careful selection of adhesive. But then of all the ones that worked, like part of the challenge was the adhesives industry wants to tell you, oh, this one's going to be really, really strong.
I don't want really strong.
We don't want it to be
I need
strong.
just a little strong.
Because this was the first thing, armor beyond just normal 3A that we penetrated. And inside you can see like these yellow, it's built out of these yellow cards right here. I think that makes it better, yeah. These yellow cards. We would do a test where we wanted the jacket to strip off. It would break through the red part and it would strip off on that very first layer. And if it drug it into, so like some adhesives were strong enough to drag it like halfway through there. And that's no good, because the adhesive is keeping the jacket on, dragging that far through. That is like, it magnifies the volume of material that you have to effectively destroy in order to keep penetrating, right? So if we balanced it so that it would survive firing, it would survive all the way to the target, but then once it hits the armor, we want that jacket to come off so that only the penetrator, only the core is moving through there, and it minimizes the amount of armor that we actually have to destroy in order to penetrate. That makes sense? Mm-hmm.
There's another one. Is this scalable to 12 gauge? And that's kind of a whole other thing.
Well, no, but
there are better, more fun possibilities when you have a bore that size.
One of the future projects that we've started to work on, we're in the very early stages of, we've verified, what do we say, we verified some of the aspects of its function already, is what we call the 12 gauge micro grenade, if you can see that. I don't know if you know what the Frag 12 is, but we're trying to make a DIY version of that. This also will be legal, not a destructive device, because of the small, it's a quarter of an ounce or less of explosive charge is legal. So we want to put, this is a whole system so that the front end of this will be packed with explosives and
whatever else you want to put in.
You could put a shaped charge in it or something else, but like that's what we're doing. Making a 12 gauge. It has more than conventional performance, if you want to put it that way. And that shape charge also, that should blast through armor pretty well.
Yeah. Let's see. We got. Is there a way I can help fund future dev? I missed the OG donation. You can if you want. We've still got you can donate on the atlasarms.org site. It's like atlasarms.org/donate. That still funds, these other projects and things like that. The other thing, and this was came up on Twitter a couple weeks ago. It's like, why, if this is for the people, why are you trying to make money on it? And Austin touched on it earlier, and it's because it's really hard to get enough money for gun projects, through crowdfunding, but it's really easy to fund a nonprofit from a commercial venture. So if we can make money doing this, the idea is that we can feed a lot of that back into Atlas Arms research to develop more things like the 12-gauge micro grenade to release open source.
I guess my snarky comment to that is like, if you want firearms innovation without commercialization, give us the money.
Yeah.
I would be more than happy to only have Atlas Arms research and not manufacturing, but there's not that much capital out there interested in donation. So
Playmaker 2007, is the problem with the GG a lack of a rigidity or too loose tolerances? And I think the answer is yes.
Yes.
Austin brought me in to look at something, and we had a dial indicator set up on it with what plug gauge was that? What ZZ or whatever it was? XX plug gauge, and it was touching it, and then you would just press lightly on the top of the Ghost Gunner, and it would flex the spindle. How much? A few thousandths.
Yes,
a thousandth.
Depending on how much.
So there's some stiffness issues.
But look, I want to address this also. I don't want to talk down too much on the Ghost Gunner.
It's a useful machine.
Look, it has a lot of potential. It really does. Look, we're developing stuff for it. We are Ghost Gunner developers over here, and if the Ghost Gunner weren't the best shot at making home production of the Dagger as turnkey as there's a reason we're using it. We think that a lot of its potential, unfortunately, has been killed because the guy calling the shots over there is more interested in making a bunch of money to have fun days in court than with making a reliable product. That's what we feel. We think that the engineers over there are great. They've done a lot of really cool things, like how it probes, fantastic. There's just a lot of problems with it to make it harder to do things that aren't finishing 80%, which is why the to this day, after all this time, the platform is still limited to finishing 80%. They've got they've got the other stuff. They've got the 0% kits or whatever, and they're working on the you can get your Ghost Gunner 3 refitted to be a 3S now. We don't have one of those, and we're also we do have gratitude for Ghost Gunner for
giving us the machine,
for DD sending us this Ghost Gunner 3 to work with. Early on in the project, at the very beginning of it, I knew we were going to make Ghost Gunner code, so I bought a 2, which again, like what I'm telling you, back in those days when we had very little money, that was an enormous purchase to try to make Ghost Gunner code. And then, of course, several months after that, they came out with a 3, and we were just, oh no, what did we spend all that money for? And they gave us a 3. So we are really thankful for that, and we're doing the best we can with the machine. And we have good plans and future projects built for it. So I don't want to be too hard on the Ghost Gunner.
Hummers kick ass. Speak for yourself. I want to mass produce them at home. I hope you are able to. I genuinely do. And if you are able to, please share what you learned from it with everyone, because the easier this is to DIY, the better. We'll have other things to make money on. So if the round can't be, quote, fired from a pistol, then you can use tungsten. The problem is it's kind of ambiguous. Yes, that's been the issue with that that question. What's a handgun? It's like how many had to have been made, because it talks about like available on the commercial market or something like that. It doesn't say how many
They're
or
normal channels.
they're normal channels of commerce. Yeah, it's some weird, it's ATF. Let's see. Why not plate the jacket in copper? Because we're trying to do something really light. And that's one of the kind of key things with this bullet. Yes, Ladderman, you actually got that right later. Let's see. Fuse construction will be everything with that in regards to the micro grenade. Well, in this case, the detonator, which we've actually tested that functionality.
Yeah, okay. So, there's the detonator, which here's one thing that our early testing in Flagstaff, and actually Will, goes by Suck by Tony, helped us with this, is we have verified that you can set off ammonium nitrate based explosives with a small pistol primer. It is very easy. You don't even have to use a magnum. But we have verified that, and the fuse mechanism, it's actually really interesting. At least I think it is. What I've come up with, the idea is that you will have a hammer in there and the primer set deeper in, and that hammer will have an integrated firing pin. But if you can see these little pinholes, I don't know.
I saw it. It's there.
Okay, if you see those pinholes, those will have pins in them. And the fins, when they're in the shotgun shell, they'll be closed up like this, keeping those pins, those retaining pins, in place. When the slug itself exits the muzzle, then these fins get deployed by aerodynamic action, and because of the shape of them, they will start to spin the slug, and that spin will throw the pins out, and those pins being out will no longer be retaining the firing pin and the integrated hammer. And so then on impact, the hammer under inertia will fly forward, hit the primer, and that will detonate the charge. So fusing is a critical part of that, but don't worry, we've got methods.
JD Hill talking about oddball calibers. Actually, that's something that we've there's a lot of old African big game cartridges that I think have potential here. So we'll see with that. The Dagger is available for 5.7, right? No, it is not.
Will it be? Maybe. Quite possibly.
Let's see. I mean,
I'll say 5.56 is next.
Yeah.
And because 5.7 is very similar, it will be not as big of a gap to shorten it. So there might be, but the market's probably not there. And remember that these things have to be injection molded, and that's a very expensive process. So we'll just have to gauge the support for it.
Let's see. Any plans to work with Ordnance Lab on the fun shotgun rounds?
I have reached out to them in the past.
Man, they're here in Texas, so.
And they said, yeah, we're good to go. So that would be great, especially because, like we've got the license to make the destructive device. We can make them, but they can make the explosive that goes in it, which
and the DD, but yeah.
Yeah, so they can do both. So it'd be good to work with them. They're open to it. So we'll just see what the future holds.
Yeah. I think I kind of got through all that. Did I miss anybody? If I missed any questions or something, just drop it back in there. I apologize if I read over you. But yeah, I mean that's kind of where we're at right now. It's been a long road. I know people are frustrated, and I understand that people are frustrated that we don't have anything to for you to put in your guns yet, and I have to remind myself to be patient, because I can assure you, Austin and I are both more frustrated than you guys are with how long this is taking, because I mean I haven't made money in years now. We're just burning through it, and him for even longer. So this is a big deal for us. It's kind of we want it too. We want it really bad, and we're doing what we can to do it right. And I don't want to. Neither one of us wants to put crummy ammo out there. And so, we're two guys, Will and Lauren. There's three of us really here working on this, and just ask that you bear with us. If you have questions, you can always email us. Especially if you're a donor and you mentioned that, we're even warmer to that. So, there was what? Can we talk more about the gas gun?
The gas gun, the fluid propellant.
Yeah, I think that's what you meant. Monkey with the wrench.
Yeah. So I used to be very tight-lipped about projects, because I don't believe in intellectual property, but I do believe in keeping your mouth shut about what you're working on. But anymore, it's like there's so much to do. If somebody takes a project and run with it, great. At least I didn't have to do it, and it exists in the world. So that'd be great to see. There is a class of energetic chemicals called nitrous oxide fuel blend. And the idea is you take nitrous oxide, which is N2O, which is an oxidizer, and you mix it with the fuel, which would be carbon rich. So it's an oxidizer. You mix it with a reducer, and you have a bipropellant of sorts. So it turns out that there are some nitrous oxide fuel blends that have a specific energy, that being basically the explosive power or the combustive power per pound or per unit of weight or mass, that are 5/3, as in 167% as the specific energy of smokeless powder. So they have very, very much potential, you could say. There, for a long time, from the 1940s to the 1990s, there were a lot of efforts for, I guess, like the Western nations that eventually became NATO, to use fluid or liquid propellants in artillery, right? So like most firearms, like fundamental firearms innovation actually starts with artillery or for large bore platforms and then moves down to small arms. And this is no exception. Essentially, they found out there were two ways to do it. One just didn't work. It wasn't consistent enough, and they couldn't get consistent ballistics out of it. The other way was extremely consistent and extremely high in performance, but the logistics of it were not field practical, as in it didn't make sense to deploy it as an actual weapon of war because of how complex it was to field and to service and to feed and all these other stuff. But that was liquids. Liquids are one of 4 different phases, common phases of fluids. Gases are another. And then there's plasma, which is an electrically activated gas. And then there's a supercritical fluid, which is to say above the critical temperature and pressure, above the critical point of the fluid. If you want to know what that means, look it up. It's a chemistry or a physical chemistry kind of thing. But basically it means that over a certain over a certain temperature and pressure, it is neither a liquid nor a gas, but behaves similarly to both. And when in nitrous oxide, the way that it would be, the fuel blend, the way it would be stored, it would be used as a liquid, a gas, and or a supercritical fluid, depending on how we metered the propellant. Figuring out how to meter it will be very, that's the project, right? Like that. Figuring out how to make that happen is that's what's going to take a lot of expense, a lot of time, and that's what we need. Like 10 years from now, we might start that. It will take very much money, and frankly, I could spend the rest of my life working on it. But it's not as simple as it being a liquid, so it won't fail for the same reasons that the stable liquid explosives propellants would. And these two chemicals that I intend to use in the blend, one of which is nitrous oxide. Even though it's used as an inhalant drug regularly, it's still legal. Why? Because it's so important for industry and for consumer goods that the government can't feasibly ban it or restrict it without pissing people off. So, like, for instance, you buy whipped cream in a can, like Ready Whip, nitrous oxide is the propellant. So you can't tell grandma she can't put whipped cream on her Thanksgiving pies because, somebody's going to use it to make firearms propellant. So it's kind of unbannable in that sense. And likewise, the fuels that we could use with it are, you can't ban them without throwing very basic industry and agriculture into a tizzy. So that's the background.
Can we expect a Dagny Dagger for the bug assault?
I wish. Actually,
we have a few of those things around here.
I just got their revolver like a few weeks ago, I think. And
Austin has discovered the red eye devil here in the hill country. It's a katydid that can eat birds, and it freaks them out. Everybody
in Texas is like, oh, the hill country, isn't it beautiful? Isn't it beautiful? Okay, so we have geckos running around our house, but we're like, okay, I don't care. The geckos can run around because they eat all the nasty spiders. Meanwhile, we also got so Lauren was stung by a scorpion putting our daughter to bed like a month ago. There's scorpions all over the place. There are those giant 8-inch centipedes that last time we caught one, I had to throw it outside and I used rat shot to kill it. If that gives you an idea of what kind of monster this is. And now we got katydids that eat birds. So yeah, we're big fans of the bug assault and that revolver that they've got. Apparently, Michael says it blows. What do you say? Did that scorpion?
Yeah, I shoot scorpions with it, and I shot one that was in my kid's room maybe like 3 or 4 weeks ago, and it was completely obliterated. I couldn't find anything, and then we got one of those UV lights like a week later, and I think I found like part of a claw like 6 or 7 feet from where the scorpion was when I shot it. So
no joke.
I wonder if you could consider that almost a gas gun because it does use CO2. No,
well, whatever the
anyways.
case, we wish we could. Anything we can do to support bug assault, we're down.
Yeah. Photon, can we expect it for a flintlock? There's also, when will we have it in a 155 howitzer? I mean, like, hey, guys, the basics are out there in the open source manual, and I'm excited to see whatever y'all want.
We have been seriously approached twice by people who are really into the air gun space, making this type of bullet for air rifles. So that's something that we would definitely consider in the future, especially because we could just easily adapt some of the pistol designs that we have. We do that. Is there
But technically, the gas gun would not fit the definition of a firearm. Is that correct?
It would fit the definition of a firearm.
It's still explosively.
Unfortunately.
Yeah. So, yeah.
Any other questions, or I could finish my story of how we got to this point.
Yeah, sure. I mean, we're kind of at the end, but
yeah, I think so. To go back to that, guys, the only question that we had sent by email that I thought was really good, talking about the success of it. Part of in my kind of like dark depression that I talked about, it's really hard to keep myself energized about this. And you start by, and when you have success, it's great. It's like, well, it is objectively the best bullet that exists in America as far as the public knows, right? As far as I know. And that's really exciting, but when you work on it every day, it just gets to be old hat. And even the advances you have are just like, oh yeah, well, I was already expecting that. That was already expected. People already wanted it. And it seems like whatever it was, if you have success, then you were already trying to get there. It was almost already expected. And that's a tough trap to fall into. And to tell you the truth, there's one thing in particular that I would think about to try to get through that. And I am really proud of that. So that the measure of success that I might be proudest of is that so when Michael came onto the project, we were being courted by other people who wanted to invest in the commercial operation. And I was starting to consider it, and Michael convinced me it's okay. We've got the money, we can squeak by, we can do it, and the company will stay ours, and we won't have to be beholden to corporate interests. We won't have to put, making as much money as possible above the open source aims of the company, and just making this technology. We would kind of save the soul of it, not having to sell parts of it off, and that was great. One of the investors that approached was a cryptocurrency whale. And man, I was excited to have him interested. It really looked like we were gonna take this guy's investment. And frankly, he was probably a billionaire. In fact, after we started talking to him, crypto boomed. And I would be very shocked if he's not a billionaire now several times over. But that's kind of a feather in my hat, in our hat. We never solicited for investment ever, not once. People approached us. They asked us about it. We put a frequently asked question up on the website, but never solicited. And again, I come from a startup. I was in a startup culture before, when everybody, it's just like, who do you know? How can you get money? It doesn't matter what the product is, just do whatever. Don't only do the development you need, even if it's fake. Do the development you need to get the investor capital. Once you got the investor capital, then maybe you do a real project. We never did that. We never looked for anybody else's money, and yet we had people contacting us saying, we want to invest. This is going to be great. I want in. Including somebody who has no reason, right, to be in the firearms space. Somebody who makes all the money from cryptocurrency, and they know, they could see in us that this is for real. They were confident in us, and me being really self-critical, that really helped me out. Since then, we learned that one of those other investment offers was from a billionaire who is actually quite popular. If we said his name, you would look it up, easily know who it is. He's quite popular, very into our project. We didn't know who it was when he reached out to invest, but only later he approached us to work with his company on a completely different project that he wants to contract. He is contracting us to do design work on. Very popular billionaire. And what's really cool about this is that there are fewer than 1,000 billionaires in America. And you figure that if you got $1 billion, you know what money's about, and you know what makes money and what doesn't make money. And they could be anywhere, right? You travel around as a billionaire. Again, every startup in the country is trying to court you, is trying to buy your favors, is prostituting themselves before you, and two of them, so 0.2% of the mega capital of this country came to us without any solicitation, without us ever asking anybody publicly, generally, or privately for any money. And I would say that is the measure of success that has made me know in my moments of self-doubt, we're going to be fine. No matter what happens, no matter how short we might have to sell the bullet, no matter what the ATF does or what injection molding can or can't do, we're going to be fine. And we're going to come out of this with a great start on the next project. So that's one thing I wanted to say.
It's not Eric Prince, but I wouldn't be that mad if he wanted something to do with our bullets. So we are not selling equity in the company. And we have not, well, I mean, we've had kind of passive talks about an evaluation of the value of the company, but honestly, we're self-funding. We're not doing this out of debt. We're not borrowing money generally to do this. And the value in it for us is, okay, I mean, there's the question, we could go raise capital or whatever. We're not interested in doing that because, in fact, that first investor that reached out to us had a very honest point. He said that when you look for when you're looking for outside capital for your company, it's a question of how much do you want money now in exchange for control later? And that's the balance you got to play. And when you consider that, Atlas Arms manufacturing and research are very ideologically motivated, an investor is going to be capital motivated. And we know that if we take that kind of investment in exchange for equity or control, we could lose that ideological drive that has helped us create the things that we're trying to create and to do the future things we want to do. So Tesla branded Dagny daggers. Yeah, I don't know about that one. No. So
if it helps you any, we're not big boosters in Musk around here.
Yeah. So, yeah.
And I'll say, finally, that brings us, I talked about everything in Arizona. It got to a point where it's like, okay, we're closing in, we're getting done on optimization here, which was the biggest slog. It's one thing when it's like you first see the product successful and you got something. Optimization was the key, right? And that's what makes the Dagger great. Okay, now that we made the bullet penetrate armor, that it's pretty good in ballistics gel. Wonderful. That means we'd have a product. But it was a long road of optimization to make sure that our 9mm is the best 9mm. And we did all of that optimization that none of the other ammunition companies do, or else they would have the best. So, $50,000 and a 28-year-old, unemployed engineer
Right.
put together more than those other companies. Why? Not because I had vision that nobody ever had before, but because we cared and we tried. We did the optimization. We did the painful work of it. That optimization was hard. Nearing the end, okay? So Michael's been in talks with us. We're talking about, okay, we're going to ship out from Arizona to Texas to commercialize this thing because Michael's connections had a space for us to do this here, to start commercialization. And I knew about a year out, a year before we came to Texas, I knew, okay, we're going to gear up for commercialization. So we want to end up in Oklahoma. Well, we're kind of open to some other options, but really thinking about going back to Oklahoma. I'm from Oklahoma. Texas law bans armor-piercing ammunition, so we can't stay in Texas. Thinking about going back to Oklahoma, I called every screw machine shop in Oklahoma that'd be good for high volume machining of the core and the jacket. And this was during COVID, and they were very happy to have our business because oil and gas, which controls most of the machine shops in Oklahoma and Texas, was in a bust because of COVID. And I lined up 2 different shops with screw machines. They were going to get us a great price on cores and a great price on jacket. They could make the tolerances. It was just all going to be perfect. And a year later comes along, and the lockdowns are over, and oil's booming again. And we're out here in Texas making the assembly machine, and we call them up and say, hey, remember that thing we talked about that we lined up a year ago? We actually need to contract you to make those cores and jackets now. And they said, well, now our lead times are out, what was it, 8 weeks for the soonest available machine, and that's just to do like a prototype run. They did not have a single screw machine, neither of these shops, to devote to the cores or the jackets. Couldn't have a machine.
And they make a lot more money on oil and gas contracts, let me tell you that.
So then come to find out, it's not just the oil and gas industry, it's everything. While COVID had everything shut down, people weren't getting raw materials. They weren't getting the parts that they need to put in their assemblies. Nobody's getting anything. So it made this whole backlog where everybody post shutdown is trying to make up for the production that was lost during the shutdown. And so we called all the shops, we called, like a dozen shops in Ohio, same thing. Everybody in Texas, same thing. Everybody in Oklahoma, same thing. We called some shops, and I don't even know where else. No machine shop will do it, and not just the ones that we had lined up, previously, but everybody. And it's not just the oil and gas industry; it's all industry trying to make up for lost time. And what do they have with these bigger companies, these existing firms, right? They already got the in with the machine shop. They already got the relationship. They're the machine shop's bread and butter, where we are a speculative project to them. So we come last in line. And just the no quote emails, man, we'd send out 6 emails and just no quote, no quote, no quote, no quote. And how are we going to do this, right? Where are we going to find it? And so finally, Michael got the idea, well, where isn't industry happening anymore? Detroit. So we started looking in Detroit for suppliers, and lo and behold, we found a machine shop to make the cores. And man, we bounced along. We're using even a different shop for the cores now, but we never ever did find anybody to machine the jackets. We lined up 2 great possibilities, wonderfully cheap, and when it came time, COVID screwed us like they screwed everybody else. So we had to go to our backup plan, which is injection molding. And you heard Michael talk earlier in this stream about the pain of that. But, we got really close to COVID screwing us over and making this not commercially feasible at all. And we found 2 injection molding shops in the entire country that were willing to take on the difficulty of this part. We chose what we know is the better one of them. And we have a great relationship with that injection molding shop. Now, he can't make this part without a special valve gate mechanism. And he was only able to find one company in North America to make.
That is the world. He was even talking European.
Was it? Okay. So the world, one in the world that was willing to make the special part of the molding equipment that we needed to do it. So, I used to think, people used to ask me, and it was like, well, since this is all open source, what happens when Federal and Winchester start making bullets of your design? It used to be that we were very, very protective of our contacts and of all of the logistics work in our assembly machine. But anymore, and I used to tell people, like intimidation is the greatest flattery, when they all know that I'm cemented in ammunition history when they start making Dagger style bullets. Now I know no one else ever will, because the road to get here, even for these very big, very wealthy, resourceful companies, it is just too much of a pain, and they will never go through all that we have gone through. So there you go. That takes us up to the present and everything that has been described as far as what we've done in the road to commercialization.
Yeah. Of course, if you guys have more questions, shoot us an email or whatever. You can give us a call. Unfortunately, our only VoIP phone is out here in the factory, and we're also in the factory's our garage. But we spend a lot of time in the office too, so sometimes we don't get the phone calls on the office on our computers. But we like hearing from you guys. We really do, especially when it's encouraging, because it's been a long road. It's been tough, especially for Austin, and just the support, having y'all here listen to us, blabber on for a couple hours has been, it means a lot to us. So, anyways, thanks, Jonathan. Yeah, I'll give the Urbit plug. We're big on like decentralized stuff here, and I've been on Urbit for a couple of years. We have an Urbit group that you can get an invite. You can get a planet if you go to atlasarms.org/Urbit. 'Cause, I, 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 and you can go to that, and it'll redirect you to a way to pick up a planet and get access to our Urbit group, where we have more open discussion and generally I'd say it's higher signal, lower noise. So anyways, it's a great project that kind of is in line with our philosophy of owning your own data and choosing how you want to interact with the world. So thanks, Jonathan, for having us in your group too. Anyways, I think we're going to shut it off for the night. So thanks again for joining us. And like I said, shoot us emails or give us a call or hit us up on Urbit if you want to talk some more. Thanks, guys.
Bye-bye.